Hey, order in the court. Order in the court. Alright, so I don't really run a court per se, but I do run a math class, and in this class, we got to have some order, folks. We got to have order, okay? And so, how do we maintain order? We follow the order of what? The order of operations. Today we are talking about not PEMDAS, but GEMDAS, and you'll see what I mean. Order in the court. Alright, so let's do a little experiment here, if you will. Okay, so what we're going to do is, same question, right? 3 plus 7 times 2. Make a line. We're going to go from left to right here, okay? Just straight up going from left to right. Alright, so let's see what happens. What's 3 plus 7? Well, that would be the number 10 times 2, and you get 20, right? Okay, that's fine. Over here, let's go, and let's do multiply first. So we're going to do multiply and then add. Okay, multiply and then add. So, 3 plus 7 times 2. Well, what's 7 times 2? That'd be 14. So now we've got 3 plus 14, right? Well, what's 3 plus 14? 17. What did our experiment show? My mic went out. What did our experiment show us? Different numbers. Order in the court. Gotta have order. Here we go. Obey GEMDAS. What is GEMDAS? Well, we're going to find out. Alright, so G, grouping symbols. Okay, so this is where the P went, usually, right? PEMDAS. Well, the problem is, we got to obey grouping symbols first. We got to do what's inside the grouping symbols first. And parentheses are not the only example of grouping symbols. However, they are an example of grouping symbols. But we also have brackets. And then we also have, and I got a circle here, the fraction bar. Okay, we use the fraction bar as a grouping symbol also. So G, GEMDAS, grouping symbols. Next. Exponents. We talked about that in the last lesson, right? What's an exponent? It's a little number on top of the base, right? So if I had 2 plus 3 to the second, I don't do 2 plus 3 and call it 5 to the second. No, what I do is I do the exponent first. So now it's 2 plus, what is 3 to the second? Well, that means 3 times 3, which is 9, and that turns into 11 exponents. All right. MD, GEMDAS. All right, so MD is multiply, divide, and I put this on the same in the same row, M/D, for a reason, because multiplication is actually division. It's true. Multiplying by a half is the same as dividing by 2. So it's really the same thing, and what we do is, when it comes to multiplying and dividing in a problem like this, in a problem like that, we do whichever comes first. So if the only thing that's left is to multiply and divide, which one do you do first? The one that comes first. And by first, I mean on the left. Like you're reading a book. Division here is before the multiplication. So in that case, you would do 10 divided by 2, which is 5, times 3, which that gets you 15. But if you had a problem like this, 1 plus 9 times 2, I would do the multiplication first before the addition. Why? Well, multiplication is part of this multiply-divide line, and that is above the add-subtract line, and I would do 9 times 2 first, which is 18. Then 1 plus 18 is 19. Add, subtract is next. Alright, so this is the same rule as really multiply-divide, in that you do whichever one comes first. So if I had 8 minus 5 plus 10, I understand that's an addition sign, but it's not any more important than a minus sign, okay? So you do whichever one comes first. So what is 8 minus 5? It's 3, and then you add your 10, and what do you get? 13. All right, so let's try this problem out. 3 plus 2 squared times 7. Okay, order of operations. So PEMDAS, right? No, GEMDAS. So G, any grouping symbols, parentheses, brackets, or fraction bars? Don't see any. Nope. Okay, so E, exponents. Do I see any exponents? Yes, I do. Right there. Okay, what is... So 2 squared. 2 times 2 is what? 4, right? So 3 plus 4 times 7. Well, so go back to the beginning. Any grouping symbols? No. Any exponents? No. No, all gone. So MD, multiply, divide. Any multiplication or division? Yes, there is right there. We got to do that first. So that's 3 plus, well, what's 4 times 7? That'd be 28. And then, well, the only thing I have left to do is add, so I really don't need to think about order of operations because that's all that's left. 3 plus 28 is, of course, 31. All right, so here's the problem for you. I want you to pause the video. This is a try problem. You'll see these every once in a while. Pause the video. Give it a shot. Play it when you're done. Let's see how you do. Okay, so we're going to evaluate this expression here. 10 minus the quantity of 4 times the quantity of 12 minus 10. All right, so what does that mean? Well, GEMDAS, right? Grouping symbols. I see any grouping symbols. Start on the outsides and work in. Grouping symbols. Yes. Okay, brackets, the first one. So, what do I do? Well, you got to restart. Inside these grouping symbols, go back to the beginning of GEMDAS. Are there any more grouping symbols? Yes, there are. Right there. Now, inside that, are there any more grouping symbols? No. Okay, so inside the parentheses, what does it tell me to do? 12 minus 10. So, again, when we do problems, we rewrite every single thing and we show all of our work, okay? So, I haven't touched the 10, so I rewrite 10 minus, bracket, 4, haven't touched that yet, times, haven't done anything with it yet, that yet. Now, the next part, let's wait, because 12 minus 10 gives us a number, and once that's done, and the only thing left in the parentheses is the answer to that, which is 2, I don't need the parentheses anymore. So, I'm just going to write 2, and then have my bracket there. Now, sometimes what people like to do at this point is say, I don't want brackets, I only want parentheses. And that's fine, so we can come back and just basically rewrite the thing with parentheses instead of brackets. It's up to you, really, personal preference. Now, go back to GEMDAS, grouping symbols. Yes, there's still grouping symbols, okay? And so now I've got to do what? 4 times 2, correct? All right, well, what's 4 times 2? That's 8. And 8 would be the only thing left in the parentheses, so I don't really need the parentheses to tell me, hey, do this first, because it's 8. So the last thing we need to do is just 10 minus 8, which is what? 2. And hopefully you got the answer 2. If you didn't, that's okay. But I would encourage you to get a separate piece of paper or flip your paper over, rewrite that, try it, and see if you can get 2 the next time. Alright, so some of you guys probably know that I love doing woodworking. Okay, so figured I'd do a problem here about the kind of tools that I buy, and yeah, here we go. So Buzzworks, let's say it's a local woodworking company. They need to place an order for a few items for the shop. The following table shows the number of items needed and their cost. What we're going to do is we're going to write a verbal model that would help us find the total cost of the order. We're going to then turn that verbal model into a numerical expression, and then finally we're going to find the value of that expression that we just wrote, which is really just going to give us the total cost. So, number 1, the verbal model. So let's think about this. What are they buying? They're buying router bits, saw blades, and some sanding discs, okay? So how many router bits? 6. What's the cost per router bit? $10, all right? So you get the idea. Now, to put it all together, it could be kind of difficult, so let's just take it one at a time. What if they just bought 6 router bits at $10 a pop? What would we say? Well, verbally, we would probably say, well, isn't it the, like, I don't know, to me, logically, the number of router bits I need times the cost per bit will tell us the cost of all the router bits, right? Okay. All right, just like that, right? The cost per bit times the number of bits that I need. Now, could you flip it around to the number of bits times the cost per bit? Absolutely, okay? But now we got some other things, right? They're not just buying router bits, they're buying saw blades and sanding discs as well. So let's go ahead and, well, the cost of the router bits would, I think, be added to the cost of the saw blades, right? And then add that to the cost of the sanding discs. So what do you think is going to go here? Well, if you thought cost per blade times the number of blades they need, you would be correct. Right there, just like that. And then the last thing, sanding discs. And I ran out of room, so we've got 20 sanding discs, and they're each $1. So yeah, it's going to look like this. Right there, just like that. Okay, so if I zoom out, maybe you can see it all. Cost per bit times the number of bits, plus cost per blade times the number of blades, plus cost per disc times the number of discs. So now let's fill in some information. How much is a bit? Well, it's $10, right? Times, how many router bits do they need to buy? 6. Now we need to add to that, what's the cost per blade? $7. Times, how many blades were they going to buy? 4. And then lastly, the cost per sanding disc was $1 times the number of discs that they needed, which was what? 20, just like that. All right, so this is really important. We need to understand that this was the verbal model here, and this is the numerical expression. Why is it numerical? Because it's got numbers, numerical, right? Okay, so the last thing we need to do is obey some order of operations. Well, I've got lots of multiplying and lots of adding. What comes first? Well, GEMDAS says multiply comes before add, right? So let's do all the multiplying. So we've got 60 plus, what do we got there? 28 plus, what do we have there? 20. Okay, 60 plus 28 plus 20. So what do I do next? Well, now all I have left to do is add, and since it's only addition left, I could actually do those two first. But let's really just go left to right. I think that's easier, just go left to right. So 60 plus 28 gives us what? 88 plus our 20, and lastly 88 plus 20. So 88. So 98, and then finally 108. And what were they asking for? What is the final value or the total cost? So we need to label our answer, of course, with $sign. So there you go. $108 is the final cost of that order. All right, y'all, that's all I got for you on this one. Look forward to seeing you in class, talking more about GEMDAS, order of operations. Keep order.